In this short video, we're going to give you an overview of the Foundation Services timeout driver. So we're going to be using the periodic mode code snippet, and in some of the subsequent videos, we'll use some of the other use cases. We're going to be validating the functionality using the MPLab data visualizer. So if you're new to that product, this is a great series to give you an overview there as well. Let's get going. So in MPLab X, as we plug in our kit, we get a welcome page. In the output window, we can take the MCU part number, select appropriate tool, compiler. We can open MCC. And looking at the timeout driver under Foundation Services, well, let's first check the version. If we don't have the latest, we can mark for load. And you can see how the library is updated. So timeout driver is a hardware abstraction layer driver supporting function schedule and stopwatch functionality. So we can open documentation by clicking on it. And here we can see the major modes, scheduler and stopwatch mode, and also a functional description. For example, the timeout driver uses a linked list implementation. Okay, so let's add this driver to our project. Here we can see that we have a number of different options and the RTC is selected by default. And here, if we change the driver, we can see that the timeout driver information, timeout driver uses TCA0. And if we update this to the RTC, the notification is updated as well. Now we're going to use a frequency of 1 kilohertz, making the timing simple. And going back to the timeout driver, we can see different use case examples. One-shot mode, for example, creates simple timers that can run once. The payload mode passes a certain parameter to the timeout, and here the periodic mode is just a simple timer running at a particular period. Notice as well that we must enable the global interrupt, and here the overflow interrupt is enabled in the RTC, so that's why. So as we click on the interrupt manager, enable global interrupt, that notification goes away. We're going to validate the timer using the data visualizer. So notice how similar to the kit welcome page, we get the kit recognized here in the data visualizer, and we can plot all pins. Now we can imagine that there's not really much happening on this kit, but we can see that something happens when we push the button. Okay, so let's go back and to the kit window, have a look at the schematics. And we can see that there is one of these debug GPIO connected to the switch. And the switch itself doesn't have a pull-up, so that could indicate the reason for why the pins seem to be quite sluggish. So we're going to add these two. So under the pin manager, PC7 input, under the pin module, and it's the switch that is going to need a pull-up enable. The other one was debug GPIO 1, which was the LED. Okay, so let us now generate code. So in the project, under source files, here's our main, as expected for an MCC project. And under MCC generated files, we see under examples, there's a timeout example.c. So here we have a description of the periodic timer. After adding an event to the handler, such as a pulse or LED toggle, calling this example will run the timer and execute the event repeatedly. Then there's some other notes here. Include the timeout example header file in whichever file the timeout example functions will be called. Okay, so here we can see what's basically happening. We have a timeout example create scheduler. This has a timeout of 1,000, which is our 1,000 tick timer. We come into the handler. So in our application, we're going to just use a debug GPIO and toggle that. And we are getting a warning here, unable to resolve this identifier. And here there was a note If you're using GPIO operations, also include pinmanager.h. So here we add pinmanager.h, and you can see now that that is resolved. So if we want to call this example from main, we can do that, but we must give an include to generated files, examples, and timeoutexample.h. So to verify that this is at least working, we're going to set a breakpoint there and debug the application. So we hit that breakpoint as expected and hit it again after about a second. So if we uncheck the breakpoint and run in the data visualizer, you can now see this timeout roughly every second. So we can pause and add a couple of cursors. And you can see the delta time is about a second. So this application is behaving as expected. So what we did is we called timeout example create scheduler mode from main, and in order to do this in main we had to add this include to timeoutexample.h. In timeoutexample.h, in order to use the generated GPIO functions, we had to add pinmanager.h here. What we can do is we can cut the example from here. I'm going to copy and paste in to main first to show you why you need to cut. If we build now, you can see that we get build errors because there's a lot of duplicated functions. So this goes away if we just remove those functions. And here we can set the breakpoint as before, and we can remove the include to timeoutexample.h. So we hit our breakpoint, and we still have the functionality that we had before. But what we can do in the data visualizer is refactor the way that this is displayed. So on the top we just put GPIO 1, and on the bottom we add GPIO 0. And the functionality of the application is now much clearer. In the next video we'll look at the code snippet for the one-shot timer.